Hi everyone, myself Soshya VC, Assistant Professor, Department of ECE, VVIT. So, today I am discussing a topic based on digital image processing, that is scalable face image retrieval using attribute enhanced sparse codewords. Photos with people like family, friends, celebrities are the major interest of users. Thus, with the exponentially growing photos, large-scale content-based face image retrieval is an enabling technology for many emerging applications. In this work, aim to utilize automatically detected human attribute that contains semantic use of the face photos to improve content-based face image retrieval by constructing semantic codewords for efficient large-scale image retrieval. By leveraging human attributes in method name, attribute enhanced sparse coding and attribute embedded indexing to improve the face retrieval in offline and online stages. In this, figure A shows the similar in low-level appearance, that is, features are lack of semantic meanings. Face images of two different people might be close in the traditional low-level feature space. But in B, by incorporating high-level human attributes, that is, gender, into feature representations, we can provide better options for the face image retrieval. Another figure shows, that is, from figure A face image contains rich content information, that is, hair color, skin color, race, gender. Using automatic human attribute detection, we can describe them in high-level semantics. For example, male contain -0.35. Suggests the person is unlikely a male, and brown hair 1.44 implies the hair color tends to the brown. In figure B, the same image after pre-processing steps in prior work for face image retrieval or face recognition. They normalize the position and illumination differences between the faces and exclude background contents. Such common approaches sacrifice the important context information, that is, using automatically detected human. Due to the popularity of digital devices and the rise of social networks like Facebook, Instagram, there are largely growing consumer photos available in our life. Among all those photos, a big percentage of them are human with faces. The importance and the sheer amount of human face photos make manipulations of large-scale human faces images a really important research problem and enable many real-world applications. In this method, address one of the important and challenging problem, that is large-scale content-based face image retrieval. So, given a query image, that is content-based face image retrieval tries to find similar face images from a large image database. It is an enabling technology for many applications including automatic face annotation, crime investigation, etc. This is the system overview of sparse coding technique. So, initially consists of a query images and a large scale image database. From this, initially selecting a query images, pre-processing is done, that is face detection, facial landmark detection and face alignment. The same procedure is happening in large scale face image database. So after the pre-processing step, the faces are aligned, the background of the face is removed, then local patches are detected, that is each part of the face is detected. Then attribute enhanced sparse coding. After that, attribute embedded invert indexing. After the preprocessing, another step also can be done, that is attribute detection. That is, for example, male is a attribute, white is a attribute, Asian is a attribute, black is a attribute, glasses, lipstick. After all this process, we can get a similar faces at the output. In attribute enhanced sparse coding technique, that is ASC, this equation contains two parts, that is dictionary learning and sparse feature encoding. By using learn dictionary, if the sampled patches provide a set of over-complete bases that can be represent input data, because learning dictionary with a large vocabulary is time consuming. That is, training 175 code books with 1600 dimensions take more than 2 weeks to finish. We can just use randomly sampled image patches as our dictionary and skip the time consuming dictionary learning step by fixing D in the equations. In attribute enhanced sparse coding, figure shows the comparison between attribute enhancing coding method, that is SC, ASCD and ASCW. Colors denote the attribute of the images and the shapes indicates the identity. Because of SC only, consider low-level features. The images with the same attribute might be assigned to different dictionary centered. In B, using dictionary selections to force images with the same attribute be assigned to similar dictionary centroids. However, ASD uses attributes with a hard assignment. When the detected attribute is wrong, the result will be undecided. In figure B, blue triangle in the bottom right corner is assigned to totally different code words from the other two triangles. In figure C, using attribute weights instead of inflexible dictionary selection, even when detected attributes are not preferred, it might still be able to retrieve correct images if appearance of the images is similar enough. This figure shows attribute embedded inverted indexing. That is, the method describes the construct code words enhanced by human attributes. For each images, after computing the sparse representation using this method, we can use code word to represent it by taking non-zero entries in the sparse representation as code words. That is, from this figure, it shows the illustration of attribute embedded inverted indexing. That is, by considering binary attribute signature in system, we can skip images with large Hamming distance in attribute Hamming space and improve retrieval performance when traversing the code word index in the online stage. Finally, the figure A and B shows two query examples of SC and ASCW respectively. The red box indicates the false positive, and the number below each image is its rank in the retrieval results, and the number in parentheses represent the rank predicted by SC. That is, the improvement of ASCW compared with SC is probably contributed by the attributes such as eyewears and hair colors. Even though some attributes are not always consistent with the same person, we can still retrieve the image using ASCW. In figure C and D show two examples using this method. Using human attributes like hair colors. We can gather information from not only face regions. That is, therefore, we can still achieve good performance under the conclusions. Thank you.